Okay. Now, problem three, example one. So let's read this. So it says Zach and Killian are racing each other on their bikes. They both leave their house at the same time, but they travel at different speeds. Their motion is represented by the position versus time graph below. So here's their motion right here. Now it says describe Zach and Killian's motion as they ride their bikes, assuming they travel along a straight road. Remember to include the starting point, the type of motion, the direction of motion, and to compare and contrast Zach and Killian's motion. So let's break this down into parts. So first it wants me to include the starting point. Okay, so I'm going to go ahead and start writing here. Let's see if this works. Hold. There we go. All right, so Zach and Killian are both moving away from zero. Okay, so I said Zach and Killian are both moving away from zero. Now, I said that because both of their lines are going uphill. If one of them had been going downhill, then I would know that it's going towards zero. But since they're both going uphill and zero is down here, that means they're going away from zero. Okay, now it wants to know the type of motion. So here's what type of motion means. Tell me about the speed. All right, so they're moving away from zero at constant speed. All right, so Zach and Killian are both moving away from zero at constant speed. We know their speeds are constant because their lines are straight. I don't have like a curving line or anything like that. That's not what I see. I see a straight line. That's constant speed. All right, oh, and a period. Okay, next it wants to know about the, oh, the direction. Look at that. Psh, I already did direction. So they're both moving away from zero. Let's do that. Okay, so I didn't really include starting point. So I've set the direction, I've set the type of motion, but I missed starting point, didn't I? Jeez, Mr. McSparron. All right, so I'm going to say both people start down at zero. All right, there we go. So now, geez, that was almost bad, guys. All right, so now I've done my starting point, I've done my type of motion, I've done my direction. Now it wants me to compare and contrast. Okay, so far we've said they both start at zero. They're both moving away, they're both constant. But if I look at my graph, well, I know they're not the same motion, so what is different about the motion? Well, if I look at it, I see that Killian's is steeper than Zach's. Okay? So what does that mean? Well, remember this. Steeper equals faster. All right? Steeper equals faster. Steeper equals faster. All right. You got to remember that. So if I look at it, then I know that Killian is moving, her line's steeper, so she's moving faster than Zach. Okay, so that's good. I think I've gotten everything. Zach and Killian, they're both moving away from zero at a constant speed. They both start at zero, and Killian's moving faster than Zach. I like that for a description. So that's all we need right there. All right, now it wants motion diagrams. Okay, so remember, let's start off with what every good motion diagram needs. It needs an axis. The axis has an arrow at one end, and it's got a zero at the other end. Now let's talk about Zach and Killian. So I know that they're both moving away from 0. So what the important first thing I know is that their lines are both going to go that direction. I'm not going to have any lines going back that direction, okay? I won't have that. So let's erase all that. Okay, so if I know that, let's focus on, let's do Zach first. Okay, so if Zach is moving that direction, I'm just going to draw some dots for Zach. Now, I happen to know that Killian's going to move a little faster. So Zach's going kind of slow. So I'm going to ahead and make my dots close together. And my arrows will be a little shorter. Remember, short arrows are slow. Let's put that somewhere. Let's write that over here. Short arrows are slow. Okay, so that's Zach. We'll label that as Zach. Now Killian's going faster, so Killian gets a little bit more space, and Killian gets longer arrows. So now because Killian's arrows are longer, I know that she's going faster than Zach. There's Killian. All right, so we said short arrows are slow. Well, that must mean that long arrows are fast. Sorry for the bad handwriting there. Long arrows are fast. Short arrows are slow. Killian's arrows are long. Zach's arrows are short. It's important that they're both going to the right because both of their graphs were uphill. If I had had a downhill line, then I would have arrows going back this direction. But I don't have that. So we shouldn't see that in this question. All right, there we go. That's question 3.